Welcome to the heat and temperature unit of the grade 7 science curriculum in Alberta. My version anyways. Um, this little video is going to talk about, I'm going to go over what heat technologies are and why we consider them heat technologies. We're going to look at some examples, and then we're going to look at what matter is and the states of matter as well as changes of state. So that's what we're going to cover in this video right here. Right. So first of all, what is a heat technology? It can be a lot of things. It doesn't have to be anything even high tech, right? Basically, heat technologies are technologies that use and control heat. That's the kicker right there. That's the important part. It uses and controls heat in a way that meets our needs and our wants. Not always just needs. Most of the time, probably wants, actually. So some examples of things that these are technologies that control heat. This one's probably pretty obvious. A furnace. That's the machine down in your basement that keeps your house warm, right? A fireplace. You can crank that baby up and keep you nice and toasty warm as well. A microwave. Different form of heat, or generated differently at least. And we definitely benefit that. And it controls heat, right? Cook some things. A freezer. What? A freezer? A freezer is cold. How can that be a heat technology? Well, what is a heat technology? It uses and controls heat. So a freezer controls heat in such a way that the temperature is very low. That's how it controls the heat. That is a heat technology. Winter jacket, you might think, well, how is that a technology? Well, we've designed lots of clothing for various purposes. A winter jacket specifically is meant to insulate. And what something that insulates, what it does is it prevents heat from moving, right? Keeps it in one place so we can use it. So again, we're controlling the heat. A fan, whether it's a hand fan or an electric fan, same thing. We are manipulating the heat around our body to keep us at a lower temperature. So all these things are heat technologies. Remember, heat technology is not just about keeping us warm or keeping something warm. It's about controlling the heat and using it to meet our needs and wants, mostly wants. Okay, whoops. Okay, let's go up. We've got the next thing we're going to look at is how heat affects matter. And this is, I love this part of the unit. This is where we get into some of the nitty gritty. So first of all, matter. Okay, we have to know what matter is. Matter is anything. So basically, it's matter if it does two things. If it has mass, right, and we can weigh it, we can actually measure that. So if it has mass, and it also takes up space, that means it takes up some room, right? We call that volume, right? How much room something takes up is called volume. But anyways, so if it does those two things, if it has mass, and if it does, it's probably going to take up some room. It's matter. And basically matter is everything around us, right? It can exist in 3 states. Okay. And this is something that you learned long ago, but you need to know. All things are either a solid, liquid, or a gas. And all of those things have mass. And they take up space. Even the air that you're breathing right now, we can weigh it, and it has a mass. There are certain gases that actually weigh more than the air we breathe. There are gases that weigh less than the air that we breathe. Okay, so but all of them take up room, and we can weigh them or measure them. Okay, now thermal energy. The phrase thermal energy, we are gonna use actually a fair amount, and what's synonymous to thermal energy is just heat. Okay, so heat's the same as thermal energy. I'm going to use that kind of interchangeably. We measure, actually no, let's do this one first. This is actually really important as well. Heat or thermal energy will always transfer from hotter objects or hotter places to cooler ones. It will always move in that direction. Okay, so when you put your bare hand on ice, is a good example. the cold doesn't come into your hand like we may think. The energy from our hand goes into the ice. So I always tell my kids that there's no such thing as cold. Cold is not a thing. Cold, when we describe something as cold, it just has a really low level of heat. Okay? So when we think about ice, does ice have heat? Yes, it definitely has heat. It just has a very low amount of heat. Okay? So that when we come close to it or we touch it, we have much more heat in us than ice, obviously. So the heat in our bodies will move into the ice. And so when that heat is taken away from our hand or what have you, it causes us to feel chilly, what we describe as chilly, right? All right, and here's one little last piece of information. The official unit, so we always measure things with standard units, right? And how we measure the amount of heat that something has or uses is the joule. If you go on, ask your parents if you can look at their power bill, right? Their electricity bill, sorry, no, gas bill might be a better way to go. Yeah, it's gas bill, not electric bill. So if you look at their gas bill, used to heat your home for the most part, it is measured in joules, mostly kilojoules because we use quite a few of them. Okay. All right, moving right along. The next thing we're going to look at is changes of state. So things that are solids don't stay as a solid. Sometimes if they gain enough heat, energy or thermal energy, they become a liquid. We call that melting. Okay? If a liquid is gaining heat, if it gains enough heat, it will become a gas. We call that evaporation. If something is at a gas and we actually cool it down, it will become a liquid. That's called condensing. Okay? If it's a liquid and it cools down even more, right, it becomes a solid. We call that freezing. So the little bit that I want to throw in here is, if we're moving in this direction, moving in that direction, in order to go from solid to liquid to gas, we have to gain heat or gain thermal energy. Going down this way, going from gas to liquid to solid, we have to lose heat or lose thermal energy. Okay? And that's very, very important. The other thing that I also threw on here is there are some interesting things that occur where a material can go from solid right to a gas without becoming a liquid. Okay? And we call that sublimation. Sublimation. And dry ice is a good example of this. And dry ice is just solid CO2. Okay. Now, it also happens in the other direction. We go from a gas back to a solid without becoming a liquid. That is also called sublimation. Sublimation. And an example of that one is frost. So at nighttime, right, there's water vapor in the air. So that's water as a gas mixed in with our air. And if there is a surface that's at a certain temperature, I don't actually know all the steps to it, but that liquid, water as a gas or water vapor will crystallize on windshields, on various surfaces as frost, but it doesn't become a liquid first.